Okay, in this to explore, this is still the chemistry of life. This will be part 3. And in this lecture, we're going to explore the different types of chemical bonds, different types of forces that hold atoms together to make larger and more complex structures. And so this lecture will be devoted to the study of chemical bonds. On the next few slides, we're going to talk about the bonds which hold atoms together. The bonds that hold atoms together. And let's look at the first type of bond. Okay. Let us draw an atom here. Okay. This atom is going to have, I think it was 11 protons and 12 neutrons. There are going to be 2 electrons here on this inner energy level. The 11 protons and the 12 neutrons, they're in the nucleus. And orbiting around this atom, we're going to have our 10 or 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, this structure has 11 protons but only 10 electrons. And so, normally, this would be the sodium atom, but now it is the sodium cation because it has 1 less electron. Okay. Let's draw ourselves another atom. Let's go over here and draw ourselves another atom. Now this atom, okay, let's draw our nucleus here. Okay, that's our first energy level. And it's going to have 17 protons and 18 neutrons. So with the 17 protons, we know it has to be chlorine. It's going to have 2 electrons on this inner energy level. The next energy level is also going to have, it's going to have 8 electrons. 3, 4, 5, 6, 7, 8. And we're drawing them this color just to show that they don't really matter that much. It's only the very outer energy level of electrons that matter. That's the only one that really matters. Okay, I'm going to draw that outer energy level here. And of course, it's going to have 8 electrons. 1, oops, not there. Okay, and there we have 8 electrons on the outer energy level. So this structure has 17 protons, but it has 18 electrons. And so this structure is going to be called the chloride Cl minus, the chloride anion. Okay. Let's see here. And so what's going to happen here? Here we have the chloride anion and the sodium cation. And what's going to happen? The chloride cation, excuse me, the sodium cation and the chloride anion, because they have different charges, they're going to be attracted to one another. They're not going to share electrons. They're only attracted to one another due to their different charges. The chloride chloride anion has a negative charge and the sodium cation has a positive charge. And due to those differences in charges, they're going to be attracted to one another and they're going to bond together. This type of bond, in which particles of different charges are attracted to one another, or in which ions are attracted to one another, is simply called an ionic bond, which makes sense. This is an ionic bond. And again, in an ionic bond, there is no sharing of electrons. And as we can see here, we're talking that we've drawn some of the electrons blue, and those are always the ones on the outer energy level, and the rest of the electrons are just drawn in orange yellowish color. But it's only the electrons in the outer energy level, only those matter. And those electrons, the ones that are in the outer energy level, we give them a special name. Let's go ahead and I'm going to separate these just a little. And we're going to. So we're only talking about these blue electrons on the outer energy level. Let's see here. I'm talking about. Well, I can't point to all of them. These electrons here. Well, all of them. All of the electrons that are just in the blue electrons, just in the outer energy level. These are called valence electrons. And the valence electrons, when you're talking about chemical reactions, only the valence electrons matter. And so here we have a sodium. To review, we have a sodium cation here, and we have a chlorine anion. The sodium cation and the chlorine anion, because they have differences in charges, these ions are attracted to one another and bond together, and they make this salt here. Such a bond in which ions are attracted to one another, or particles of different charges are bonded to one another, such a bond is called an ionic bond. And that's it for this slide. Okay, we explored ionic bonds on the last slide. On this slide, I will explore a different type of bond. Let's just leave it there for now. Okay, let's draw ourselves another atom. This is the energy level of the electron. Also in this atom will only have one proton. We won't worry about the neutrons. So we won't the specific isotope does not matter. And so this has to be the hydrogen atom. It has one proton, and it is going to have for itself one electron. Okay, and there's one hydrogen atom. Let's just put down here, this is hydrogen. Okay, let's see here. This is going to be the hydrogen atom. That's kind of big. There we are. Here's a hydrogen atom. Let's draw a second hydrogen atom. Second hydrogen atom shows the energy level for its electron. As before, it's going to have one proton, and it's going to have one electron. And this also is going to be a hydrogen atom. Now, both of these hydrogen atoms have only one electron, and they both want two electrons. And so, one of two things could happen. I'm going to show you this first scenario, but this does not happen. first electron, this first atom, just as before, could lose this electron and become a hydrogen, and it could become a hydrogen cation. And so this electron could actually, I think that's going to move as well, but it could become a hydrogen cation, and this electron could actually move here and to create a hydrogen anion over here, and they would have differences in charges. This one would have a positive charge, this would have a negative charge, and they would be attracted to one another like before in the ionic bond. But this is a different type of bond, so neither of these take place. And so this hydrogen keeps its electron. What happens, these two atoms decide to share electrons. So this atom comes over here, their energy levels join, and now they actually share these electrons. And so these two atoms come together to make a hydrogen molecule. Now both atoms have two electrons. Okay. And this type of bond, in which atoms actually share electrons, this type of bond is not an ionic bond as before. We call this type of bond a covalent bond. This is a covalent bond. And the entity that is created here, this hydrogen, these two hydrogens joined together, is called a molecule. And of course here, it is a diatomic molecule because there are two atoms here. And so this is a covalent bond when atoms share electrons, as opposed to an ionic bond in which one atom takes electrons and one atom loses electrons. And this is our second type of chemical bond. On the last slide, we looked at what a covalent bond is. Now, covalent bonds there are different types of covalent bonds, and they can be classified based on two criteria. And so let's set up the first one here. We'll just call this types of covalent bonds. Okay. If a covalent bond has if there are just two electrons that are shared, we call such a covalent, well, it can be represented this way, or you can just, if there are just two electrons, you can draw it as a single line. And we call this type of covalent bond a single covalent bond. I mean, that needs no explanation. If in a covalent bond there are 4 electrons that are shared, we can represent this as 2 lines between the atoms, and this is a double covalent bond. And if 2 atoms share 6 electrons, we represent this with 3 lines between the atoms. And as you can see, each line or each bond represents 2 electrons. And so in this third example, we call this a triple covalent bond. And again, These are different types of covalent bonds based on the number of electrons. In the next slide, we'll look at types of covalent bonds based on where the electrons spend their time, based on around which atom the electrons spend their time. And so, but this one, these are the types of covalent bonds based on the number of electrons. If you have 2 electrons that are shared, we call that a single covalent bond, and that's represented by one horizontal line between the atoms. If 4 electrons are shared, we call this a double covalent bond, and this is represented by 2 horizontal lines between the atoms. And lastly, if there are 6 electrons that are shared, we call this a triple covalent bond, and this is represented by 3 vertical lines between the atoms. The different types of covalent bonds. Okay, on this slide we're going to look at the types of covalent bonds based on the distribution of the electrons. And let's look at a very common molecule. Let's look at a water molecule to do this one. Okay, I'm going to draw here. Okay, I'm going to draw an oxygen atom. Okay, here we are. We're going to have ourselves an oxygen atom here. And we're going to have a hydrogen atom here and a hydrogen atom here. Those are the electrons. Now, for oxygen, there are 2 electrons shared between the oxygen and the hydrogen, and 2 electrons shared between the oxygen and the hydrogen here. And within the atom, okay, let me make sure this is hard. Okay, within the atom, or within the nucleus of the atom, okay, there are 8 protons for oxygen. And so we're just looking at the oxygen atom. It doesn't matter how many neutrons there are, so we don't care about the isotope, just the atom. And here, for hydrogen, there's 1 proton. Again, we don't even care about the isotope. And so here we have a water molecule. Okay, also in the oxygen atom, I'm going to put my other electrons that don't really matter right now. There are other electrons in hydrogen. Okay, those electrons aren't involved in the covalent bonding. And so it's just these 2 electrons that are important. Okay, I'm going to actually do something here. So we have 4 electrons, 1, 2, 3. Actually, let's just gray these out as well, because they don't really matter that much, because they aren't involved in the covalent bond. Now, here, these electrons here, I wish I hadn't put them there. Let's see if I can get rid of those electrons. It's going to be kind of tough right now. So I'll have to go back a few steps. So I don't want those electrons there. I actually want to put my protons first. So we have 8 protons here, 1 proton here, 1 proton here, and we'll put the electrons that are not involved in the covalent bonding. And now we'll put the electrons that are involved in the covalent bonding. Okay. Okay. There we are. Okay. There we are. Okay, and this is a water molecule. Now, the one thing that I want to, let's just look at this bond right here. This bond in the water molecule. These electrons here, the electrons that are shared, they if this bond were an evenly shared covalent bond, these electrons would spend half of their time around the oxygen nucleus and half of their time around the hydrogen nucleus. But the electrons spend most of their time around the oxygen nucleus. And so because oxygen is electronegative, it pulls the electrons closer to itself. And so this is a polar covalent bond. So this bond has poles. It has a negative pole and it has a positive pole. So the electrons are going to spend most of their time around this oxygen nucleus. And so this is what the bond is going to look like. Okay. And so this is really a better representation. I can do it even for both of them. Both pairs of electrons spend most of their time around oxygen and less of their time around hydrogen. This is going to leave the oxygen end of the electron of the molecule is going to be left with a partial negative charge. And we put delta negative. The oxygen end of the molecule of water is going to have a partial negative charge, and the hydrogen end is going to have a partial positive charge. Actually, I want to put it right here on the end. It's going to have a partial positive charge. And this is the water molecule. Just a few things. Let's go ahead and label the molecule. This is water. I'm not going to label oxygen and hydrogen right now. And so just know if it has 8 protons, it's oxygen. If it has 1 proton, it's hydrogen. And we'll explore this a little more on the next slide. Okay, let's look at these electrons here on this slide. Now we're just going to focus on one of these pairs of electrons. So for this one here, let's see, this is the one I want. Yes, let's put this one here. Let's put this one back in place because we're not going to really focus on it right now. We're just going to look at one of these bonds and we'll know that the other one works the same way. And for now, we're just going to focus on this oxygen and the right hydrogen. So I'm going to put it back where it normally goes. Now, we're going to take these electrons. And these electrons here, they're shown as single dots, but they move so fast they're like a cloud. So what I'm going to do, I'm going to take these electrons away from right now into these, instead of these dark blue dots. And I'm going to put a cloud of the electron cloud that goes around the hydrogen, and the electron cloud that goes around the oxygen. So let's make a cloud of electrons around. Let's put a cloud of electrons around. Let's see here. Put a cloud of electrons around oxygen. Okay. So there's a cloud. So instead of those strong dark blues, we have 2 clouds of light blue. and then there would be an electron cloud around the hydrogen. Okay, there we are. Now, because the oxygen atom is electronegative, it's going to pull the electrons away from hydrogen. So hydrogen's cloud is going to be smaller. Okay, and because the electrons are going to spend more time around oxygen cloud is going to become larger. Okay, and so that is what's going to happen. You're going to have more of those the electrons are going to spend more time around oxygen and less time around hydrogen. And so in this covalent bond, there's not going to be an even sharing of the electrons. And so this type of covalent bond is called a polar covalent bond. It is a polar covalent bond. Like just like Earth has poles, the ends of this bond are different. It has a big end and a small end, or a positively charged end where the hydrogen is, and a negatively charged end where the oxygen is. And so this type of bond is a polar covalent bond. Once you know what a polar covalent bond is, there's really no need to define its counterpart, the nonpolar covalent bond, because all others are nonpolar. For example, if you have hydrogen bonded to hydrogen, of course, since these are the same atoms, there's an equal sharing of the electrons, and so this is a nonpolar covalent bond. And so when you're talking about polar and nonpolar covalent bonds, you don't want to think about the electrons as dots or distinct entities. Think of them as clouds. And if the electrons spend more time around one atom, its cloud is going to be larger. And if it spends less time around another atom, its cloud is going to be smaller. And that's going to create a polar covalent bond, where the larger cloud has a partial negative charge and a positive cloud, and the smaller cloud has a partial positive charge. The polar covalent bond. Let us on this slide explore the last type of bonding that occurs. So we're going to start with a water molecule again. So here we have, I'm going to draw a large oxygen molecule here, and we'll put here an O for oxygen, and connected to the water molecule we'll have some hydrogens. So we're going to put an H for hydrogen here, and another H for hydrogen. So this is our water molecule. And as we can remember from before, the water molecule, on the oxygen end, it has a partial negative charge, and on the hydrogen end, it has a partial positive charge. Okay. And so this is a bond, and this makes a molecule. We have the entire molecule, but we only have the bonding that we've already talked about, the covalent bond. But this type of bonding is not going to make a molecule. It's going to be found between molecules. And so let's create a few of these water molecules. Okay, let's just make about 4 of them. That's 2, 3, and 4 water molecules. Now what's going to happen here? I don't know what would be a good color. We'll just use red here. the partial positive charge of hydrogen here is going to be attracted to the partial negative charge of the oxygen in another molecule. So there's going to be an attraction here, an interaction there. And also the partial positive from this hydrogen is going to be attracted to the partial negative of the oxygen on another molecule. And this is going to just continue, so that all the water molecules in a container, all of them, are going to end up being attracted to one another. And so whenever you have a polar molecule, two polar molecules, and the different regions of those polar molecules are attracted to either a different molecule or the polar region of another molecule, we call this type of bonding hydrogen bonding. So this is a hydrogen bond. Most of the time it's hydrogen. Almost all of the time it's hydrogen. So we call them hydrogen bonds. And so as you can see, you have, this is a polar bond here, a partial positive hydrogen, a partial negative oxygen. When the partial positive region of one molecule interacts with the partial negative region of another molecule, or the same molecule, we call that type of interaction, or we call that type of bond, a hydrogen bond. And that is the last type of bond that we will explore.